Hi, everybody. Thanks for joining our webinar session today and welcome. We are going to give folks just another minute or so to join us, and we will get started. All right, let's jump in. Thanks again for joining us today. We're focusing on DevSecOps in GitLab. I am joined by my colleague, Mary Grace Wida. We're excited to have her on with us. First off, just a couple of housekeeping items. First off, this webinar is being recorded, so you can look for that recording to come through in your inbox here the next couple of days. The deck will be included with that as well. If you have any questions throughout, please put those in the Q&A portion of your Zoom window. We have folks on that are excited to help answer those, and Mary Grace will be able to answer a couple towards the end as well. And with that, I will pass it over to Mary Grace.
Thank you, Taylor. So hi, everyone. So as Taylor mentioned, our session today will be focused around DevSecOps and compliance within GitLab. So we're going to discuss how development and security teams can work together in a single tool, allowing for a proactive approach to security, sometimes referred to as shifting left. And the aim of this session is really to provide you with an overview of what GitLab offers from a security and compliance perspective, how the scan results can integrate seamlessly with merge requests as part of the development workflow, and how to use the security dashboard as well to manage vulnerabilities. All right, so we're going to start with an overview of GitLab's security and compliance capabilities and how application security fits into the software development lifecycle. From there, we'll go through how developers, security teams, and compliance professionals can take advantage of these tools and create a DevSecOps workflow that fits the requirements of your organization. And so along the way, as I'm presenting, as Taylor mentioned before, please feel free to drop your questions into the chat, and one of my awesome colleagues will respond. And so with that, let's go ahead and get started. So before we jump into the security and compliance capabilities that are available in GitLab, just want to take a step back and kind of talk through why so many organizations are using GitLab in the first place and what problems we're solving for our customers. So really here, we are helping teams move from sequential DevOps, which you can see over on the left-hand side of the screen here, to concurrent DevSecOps, which is implemented by leveraging all of the features that are available to you within GitLab. So the reality is that even though some or even all teams may adopt DevOps in the form of tools and processes and culture, you often still find that those teams are optimizing those tools or processes locally and still working sequentially. And so what we mean by that is they're handing work off from one team to another. And this limits organizations from truly realizing the value of DevOps, where teams really need to work together and have a single conversation from the inception of an idea all the way to production around smaller deliverables. And so in a traditional sequential DevOps approach, each function is running in silos. They're using their own tools that they've selected, and they might be locally optimized, but there's still a lot of handoff and tool friction as every team hands over to the next team. And so organizations wanting a way to move faster and more efficiently are adopting the GitLab concurrent DevOps model. And this approach offers a way to get teams to work together at the same time and collaborate in a single pane of glass, so to speak, to design, build, test, deliver, and monitor code changes. And so with this approach, teams are working concurrently rather than sequentially on the product or service that they're delivering to the customer. And as we all know, changes in the code base are accelerating. So along with your development changes, you also have an increasing number of open source tools, APIs, and microservices, all with changes that need to be tracked. And so because of this, trying to scan your application using traditional methods is not really realistic anymore. You really need to empower your developers with security tools so that security can be incorporated into their CI builds and automation. So really can't leave it all to the security team to handle anymore, because today, as we all know, there are just too many vectors of attack for software vulnerabilities. So security is really a team sport, and it's everyone's responsibility. And so we as GitLab want to lead a new era where security is baked into the software development lifecycle with a single application that is purpose-built for the modern software factory. And so the value of this shift left approach that we're recommending organizations take is that with this workflow, both development and security are going to be able to work more efficiently and more effectively, leading to cost savings and less risk. So to illustrate this, let's talk about the traditional approach to application security for a moment. So in a traditional process, as a developer, you might push code to your repository, maybe you run your CI, you even use a merge request to kick off a deployment pipeline, which then might hit a test environment. And at that point, you might be saying to your QA or security teams, okay, this new version of the application is available for scanning. And this is all happening at the end of the process, after the developer has most likely moved on to their next task. And so when the scanning is occurring so late in the lifecycle, your developers are not empowered to fix the vulnerability when they're most aware of it and when they're in the context of their work, which is when it's easiest and also cheapest to remediate it. Now, when security is integrated into the software development lifecycle from the very beginning, you're treating security like any other code flaw and enabling better collaboration between developers and security teams. So you have a single source of truth between development and security, but because you're integrating security into the normal development workflow. And so with this approach, we can scan before the code is committed to the stable branch and also maintain a list of approvers to ensure the security of the main branch. And security vulnerabilities are reported directly to the accountable developer. They're able to be viewed within the same pipeline workflow. And the vulnerability can be either dismissed or an issue can be created in the same place, which makes tracking much easier for both developers and the security team. And we've found that the best way to scale application security is really by enabling development with continuous security. And this level of integration is only possible because GitLab is a single application for the entire software development lifecycle. And so in addition to providing your development and security teams with a better overall experience, integrating security into the development process also leads to cost savings, as I alluded to on the previous slide. So as you're all aware, when you develop software, most of the time you are building upon your previous work. So the longer that you're waiting to fix bugs or vulnerabilities, the more code is affected. And so then it takes much longer to resolve. And that in turn equates to a much higher cost to remediate. And so having to context switch, try to remember what exactly was done weeks or sometimes even months ago can take a lot of effort and time. And so by the time an application is released into production, it costs 30 times more to fix security flaws than it does in design, and 15 times more than in development. So this is a really significant problem. And GitLab supports the entire software development lifecycle. So within the secure stage, we offer functionalities such as static application security testing, container scanning, dependency scanning, license compliance, secrets detection, and dynamic application security testing. And you can see all of the different capabilities outlined on this slide. And our scans can be built within your merge request so that as developers are iterating on their code, they're able to collaborate with one another. They're also collaborating with the application security team, and they're empowered to remediate those vulnerabilities before they make it into production. And then also with GitLab, security teams have agency and insight into the process as well, can do things like require approvals and enforce scans in line with your organization's security and compliance policies. Additionally, security teams have visibility into organizational risk through our security dashboard, where you're able to view summaries of security findings and generated vulnerability reports in one dashboard view. So we'll get into all of this in further detail, but next let's talk about what this workflow looks like from the perspective of a developer, and then we'll do the same for the security and compliance team's perspectives as well. So we're going to start with the developer experience. So there's a lot of talk in the industry about shifting left, but what does that actually mean? So shift left is an approach that moves testing and security to earlier in the software development lifecycle. And that means moving security testing as close as possible to the developer. And so this visual here on the screen shows what this actually looks like in practice. And so the key to GitLab's approach is scanning the code at the point of code commit before the code changes ever leave the developer's hands and before their code changes are mingled with others. And this is so powerful because it provides real-time feedback to the developer about vulnerabilities in their code changes while they are still working on the code and they're enabled to easily fix it. So they can resolve those flaws before introducing the code into the main branch and before others get involved. And as I mentioned before, security still has agency and awareness of this process. And in fact, for most organizations, we would encourage the idea that security collaborate within the merge request itself as part of a review. And we'll talk a little bit later about how you can enforce these types of reviews dependent upon the severity of the vulnerability that is uncovered. So here is an example showing multiple scanners integrated into a CI pipeline. And all of these scanners are added with a simple include template line to your GitLab-ci.yaml file, which promotes shifting security left because it makes it really easy to integrate security into your workflows. And that in turn allows you to remediate vulnerabilities earlier. And because GitLab is a single application, we can leverage what's called the review app, which is a fully functioning app used to test the changes made to the code. And that allows you to run even dynamic application security tests or DAST before the code ever leaves the developer's hands and before the code is merged. And so when we talk about enabling developers to address these security findings, what does that actually look like in practice? So we just saw what the scanning looks like in the context of a pipeline. And so now I want to show you what it looks like in the merge request itself. And so here we have a specific CI/CD pipeline that successfully ran on a feature branch that has security and license compliance scanners configured. And so from this view, you can see a summary of the specific pipeline that ran. You can also see the approve button along with this dropdown here to show you the list of eligible approvers for this merge request. Also shown is a short version summary of results for each of the scanners. So you can see here the 24 new and 4 dismissed vulnerabilities for the security scanner. And then you're also able to view the full report or expand the results within the pipeline as well. And so then from there, developers can decide what action to take. So one option is to create an issue for this finding to either address it right away or in a future release. And the other option would be to dismiss the vulnerability with a comment specifying why, such as for a false positive or any type of accepted risk. And to reiterate, some of the benefits of this approach, again, every piece of code is tested upon commit without incremental cost. The developer is empowered to remediate now while they're still working in that code or easily create an issue with one click. And then the dashboard for the security team is a roll-up of the vulnerabilities remaining that the developer did not resolve on their own. And so with this approach, vulnerabilities can be efficiently captured as a byproduct of software development. And finally, having one single tool to handle all of this also reduces your costs over an approach that involves buying, integrating, and maintaining different point solutions. And so GitLab provides resources to help guide developers in remediating vulnerabilities. So when available, we will provide a suggested solution as well as links to relevant information. We also offer auto remediation for dependency and container scanning findings. You can resolve with a merge request where you can automatically implement the suggested solution. Alternatively, you can manually download and apply the patch as well. And as you can see, you also have the option to dismiss the vulnerability, again, adding a comment as to why you're taking that action. And so additionally, developers also have access to integrated training resources to help them resolve vulnerabilities. So this integration capability uses the vulnerability information to get a link to learning resources that educate developers on finding and fixing that particular security problem. And so this provides developers with trusted guidance that they can use to resolve the vulnerability with confidence. And this is also a highly effective way to retain knowledge for a number of different reasons. So bite-sized coding challenges give developers targeted hands-on skill building in that vulnerability and how to resolve it. There's also contextual learning, right? So it's presented in manageable chunks, which continuously reinforces good, secure coding patterns from a trusted source, not just enabling a patch. It also reduces the time gap between learning and application of knowledge, which leads to lasting engagement and retention. Developers also are able to grow their muscle memory to recognize those security issues while they code, leading to the elimination of common vulnerabilities from the very start of software creation. And so next, we're going to talk about where the security team fits into this process. So when it comes to separation of duties, security teams have a number of controls available in GitLab, such as enforcing when scans run, which we'll talk more about in just a moment, as well as the ability to set scan result policies, which create rules that ensure security issues are checked before merging a merge request. And so, for example, you could set a scan result policy that says if any scanner finds a newly detected critical vulnerability in an open merge request that's targeting the master branch, then require 2 approvals from any member of the application security team. And approvals have a lot of flexibility. So there's a number of different ways that you can kind of configure those. So you can really customize this to meet the needs of your particular organization and your workflow. And then in GitLab, security teams are enabled to participate in the vulnerability management process in a number of different ways. So to illustrate what the vulnerability triage and resolution process can look like, let's walk through an example workflow. So everything in GitLab starts as an issue. From an issue, a developer can open a merge request and commit code. On every commit, the code is then scanned for vulnerabilities. If a new vulnerability is detected due to the scan result policy, then security group approval is required to proceed. And if the vulnerability is legitimate, then the security approver leaves a comment on the merge request, requests changes, and a resolution. Then the merge request is passed back to the developer to make new commits. If the vulnerability is a false positive, then the security team member can dismiss that vulnerability, approve the MR, allowing for the code to be merged. And if no vulnerability was detected, then the approval process from security is not necessary and the code can be merged. And after the code is merged into main, it is scanned for live vulnerabilities. If a vulnerability is detected in production and it is a false positive, then the security team can set the vulnerability record to dismissed. And if it's a legitimate and actionable vulnerability, then the security team could set that status to confirmed, create an issue from that vulnerability, and then the development team can action the issue by creating a merge request and restarting that process. And the security team can also use vulnerability reports. So that's what you see on your screen here now. So the vulnerability reports provide an overview of all the security vulnerabilities from scans of the default branch within groups and projects. And as you can see here, you can drill down into a vulnerability for detailed information, such as the originating project and file, as well as the metadata to help you analyze the risk. And then you're also able to take action on these vulnerabilities, again, by creating an issue or dismissing them. And GitLab also offers visibility into your security risk via what we call our security dashboard. So this allows either direct security or CISO type roles immediate visibility into a group level security posture, so they can quickly understand any at-risk projects with security grades. So they are able to see burn down chart of vulnerabilities over time for the given, and for a given project, they're also able types of grades, so A through F, which is based on the number of high or greater severity vulnerabilities per project. And so again, the dashboard really offers you that holistic ability to understand and manage your security risk across your entire organization. And so these types of high-level trends and metrics provide you with that insight and data to support better decision-making and vulnerability triage. So we touched on some of the compliance pieces a bit when we talked about scan result policies earlier and enforcing scans, but now we'll discuss in further detail. So when it comes to auditing, you may need to satisfy an organizational requirement to prove things like separation of duties. So GitLab can give you information about who took action, what action they took, what occurred, why, was that action compliant, who authorized that action, where and how long did it last, and what gaps may exist. So GitLab's audit event capability helps to answer those audit logging requirements within either the UI or our API. And we also offer streaming audit events. You can actually redirect a webhook-based stream of audit events to an external logging tool, like, for example, a Splunk. And then with our compliance reporting functionality, GitLab also offers you the ability to verify that all code contributions meet your organization's security and compliance requirements. So with the compliance violations report, you're able to see a high-level view of merge request activity for all projects in a group and the severity for each compliance violation. And so an example compliance violation could be something like, a merge request being merged with fewer than 2 approvers, or an author of a merge request approving their own merge request. We also have the chain of custody report, which provides a 1-month trailing window of all commits to a project under the group, which gives you insight into information such as the commit SHA, the commit author, the date committed, etc. And then finally, the compliance frameworks report shows you the compliance frameworks that are applied to projects in a group, and we'll talk more about that in just a moment. So next, wanted to touch on an important topic that is very much top of mind for many of our customers right now. So the software bill of materials, or the SBOM. So as I'm sure you're all aware, an SBOM is a nested inventory or list of ingredients that make up software components. And then in addition to the components themselves, SBOMs include critical information about the libraries, tools, processes that are used to develop, build, and deploy a software artifact. And so in GitLab, you can use our dependency scanning to generate an SBOM. And so when you do that, you will get a dependency list, which breaks down all the dependencies and licenses that are being used in your application to help you understand the holes in your application and meet compliance requirements. There are a lot of tools that can generate an SBOM, but then the question becomes, what are you going to do with that information? And so what's unique to GitLab is that we make it really easy not only to generate SBOMs, but then also to quickly take action based on the results. So not only are you able to quickly export the SBOM in Cyclone GX format to share externally, which again, a lot of other tools can do that, but the real value is in the visibility and the context that GitLab provides this information in so that you can quickly take action on critical vulnerabilities in your application. So you're able to easily view which dependencies have vulnerabilities. You can drill down into the vulnerabilities, see if there's a suggested solution, create an issue, put it right back into the developer's workflow so that they can remediate it and you can move on. And so this isn't just about generating the bill of materials, which is great, but it's really an actionable SBOM. And so next, we're going to talk about how you can require scans to be run. And so there are multiple mechanisms to accomplish this in GitLab. So we're going to start here with compliance frameworks and pipelines. So once you define the rules and policies for your organization, you're going to want to enforce those policies. And so GitLab offers, a number of different compliance controls and automation of compliance workflows, which are really focused on enforcing those policies and separation of duties while reducing overall risk. And so to break this down a little bit further, there are three main components here. So we have the compliance framework project templates, and those allow you to create projects with issues that map to specific audit protocols, such as HIPAA, et cetera, to help you maintain an audit trail and manage your compliance programs. Compliance framework project labels enable common compliance settings to be applied to projects with specific framework labels. And then compliance pipelines allow you to actually define a pipeline configuration to run for any projects with a given compliance framework. And so what this really does is it allows you to run specific jobs, especially security jobs, on every pipeline run. And the configuration here is managed at the group level. And the pipeline configuration file lives in a project separate from your development projects. So that is where the separation of duties comes in and really eliminates any potential tampering with security protocol. And then another way that you can enforce scans to be run is with scan execution policies. And so with GitLab, security professionals can use a scan execution policy to create rules which enforce security scans for particular branches at a certain time. And so supported types are SAST, DAST, secret detection, container scanning, and dependency scanning. And as an example of what this could look like, you could set up a scan execution policy that says to run a DAST scan with scan profile A and site profile A when a pipeline runs against the main branch. And so you might be wondering when you should use compliance frameworks versus when you should use scan execution policies. So there are advantages and disadvantages to each approach. So as you can see here, we do have some documentation that you can look through in a comparison table. But to kind of sum it up, so compliance framework pipelines are recommended when scan execution enforcement is required for any scanner that uses a GitLab template. Scan execution enforcement is required for scanners external to GitLab. Scan execution enforcement is required for custom jobs other than security scans. And then scan execution policies are recommended when scan execution enforcement is required for DAST. Scan execution enforcement is required for SAST, secret detection, dependency scanning, or container scanning with project-specific variable customizations. Or scans are required to run on a regular scheduled cadence. And so either solution could be used equally well in situations where scan execution enforcement is required for SAST or secret detection when custom rule sets are not used, or scan execution enforcement is required for container scanning with no project-specific variable customizations. So the approach that you take will really depend on your use case and your needs here, but lots of different kind of options and a lot of flexibility with the tool. And we encourage your feedback on this as well, as we are thinking about, ways to unify the user experience for both compliance frameworks and scan execution policies. So next, let's talk a little bit about how you can use GitLab to enforce license compliance policies. So the GitLab license approval policies feature allows legal and compliance teams to manage policies which will require approval on merge requests whenever licenses are detected that violate that policy. And so those policies are stored in the YAML in a Git repository inside of GitLab in a security policy project. And so those security policy projects can then be linked to one or more development projects, or they can also be linked to groups or subgroups, which will then cause the policy to be applied to all of those projects inside those groups. And so by storing those policies as part of the YAML file, we can provide a full history of any changes that are made to the policy. We can do things like require approvals anytime a change is proposed to be made to the policy. And again, we can provide separation of duties to allow security, compliance, and legal teams to manage those policies separately from the developers. All right, so that was a quick overview of security and compliance within GitLab. So there is a lot more we could cover, so definitely encourage you to reach out to us with any questions. Also wanted to touch on the support and enablement that is available to you through GitLab Professional Services. So we offer a number of types of professional services engagements. So if there is something you are wondering if we can help with, please let us know. But just to provide a quick overview of some of the most relevant services available. So we do offer live training classes, which include labs. They're really hands-on. So as an example, we have a security essentials training available, as well as GitLab for project managers and DevOps fundamentals training. And these courses can really accelerate your time to value with GitLab and enable your teams quickly so that they can focus on the high priority work items that you need them to complete to accomplish your DevOps objectives. So would really encourage you to take a look at what is available. We know that getting your teams used to a new way of working or taking your existing DevSecOps workflow to the next level involves changes not only to process and tools, but also culture. And so these trainings can really help to unlock the potential of GitLab so that your teams understand everything that's available, feel excited about the tool and can take full advantage. And so with that, I think we can go ahead and transition into some Q&A.
Great. Thanks, Mary Grace. Before we jump into a few questions, I just wanted to let everybody know that I have opened up a feedback poll. We'd love for you to take a quick moment to provide us with a little bit of feedback on today's session. Just a couple of questions there. And with that, I will jump into some of the questions I've seen come through. The first one here, this is all great, but it's a lot of information, so many different things to talk about. What's the best way to get started with application security in GitLab?
Yeah, so that's a great question. So kind of building off what I just said in regards to professional professional services, we understand that adopting a new workflow or using new tools involves a lot of change. And so we encourage teams to start small. We advise enabling 1 or 2 scanners at a time. So keep things really simple. Start with secret detection and dependency scanning. So secret detection only has 1 analyzer. There's no build requirements. It's relatively simple findings. Is this a secret or not? So that's a good one to start with. And then it's also a good practice to enable dependency scanning early so that you can start identifying, any existing vulnerable packages in your code base. And then from there, you want to really give your team time to get comfortable with the vulnerability reports and establish a vulnerability management workflow in GitLab. I've also seen customers be really successful with identifying a team to pilot the new approach. So that can get you some early wins and provide an example for other teams to follow. And we do also have a guide and a video walkthrough for the steps and kind of order of operations to follow when getting started with GitLab application security as well. So we will make sure to provide the link to those resources. But the bottom line is you want to start small and iterate as you go so that you can give your team time to get used to the new workflow.
Awesome. Next question here. We would like to start using GitLab scanning capabilities, but we have a management mandate to use a certain tool for static application security testing. Does GitLab integrate with other security tools?
Yeah, so GitLab does integrate with pretty much any other security tool you can think of. And then you also then will see the results from those scanners in your vulnerability reports as well once you have the integration configured. So we do have documentation on our kind of official security partners, but again, GitLab is a very flexible tool. And so if you're wondering if we integrate with a particular tool, would encourage you to reach out to us so that we can help to guide you accordingly. Of course, we'd love for you to use all of GitLab's scanners, but we understand that's not always possible. Sometimes you'll have to use other tools as well. So our scanners play really nicely with other tools, and you can even use them together. So you could use GitLab's, SAST scanning in tandem with your existing tool to augment the capabilities of your existing scanners.
Great. And then one more here I'm seeing. Does GitLab provide security training for users? How can we get more information about training opportunities available?
Yeah, so in addition to kind of the professional services offerings that we have, which are going to be the most hands-on and include like the lab components and really give you practice with the tool, we do have a number of free resources. So we have YouTube videos, we have the GitLab Learn platform, which we can also link you to as well, which includes things like self-paced certifications and training courses that you can go through. We also have really great documentation. And again, with any kind of questions that you might have, we encourage you to reach out so that we can help to kind of connect you with the appropriate resources.
Great. Well, thank you, Mary Grace, and thank you everyone for joining us today. We appreciate you taking some time out of your day. As a reminder, we will be sending out the recording and the deck here in the next couple of days. And with that, we will wrap up today's session. Have a good day, everybody.